The crosshatch test is used throughout the coatings world to determine the quality of adhesion. This is both adhesion to the substrate and adhesion between layers of a coating system. A coating may look very good over a larger surface, but the crosshatch test is designed to determine how well each tiny section adheres. The test. The objective of the test is to isolate small islands of coating on a surface and assess how well the layers adhere. To achieve this, a small grid is cut into both the coating and the substrate. This essentially isolates the full system, substrate and coating layers, into individual stacks. A piece of tape is then pressed firmly over the grid and removed quickly. There are kits with special blades and tapes for ASTM standards, but quick testing can be done with a razor blade, box cutter, or other sharp blade and masking tape. You do not need to cut deep into the wood, but the objective is to cut through the entire coating layer. Also, smaller squares will be a more difficult test to pass and, therefore, a better check. Good adhesion. When adhesion is good, there is a chemical or at least physical compatibility between the two surfaces. The molecules will either form actual chemical bonds or may also become so entangled, think like Velcro on a molecular level, with one another that they become extremely difficult to separate across the entire coated surface. When a crosshatch test is done, the tape should come off relatively clean, and the coating should appear intact over each section of the grid. Poor adhesion. When adhesion is poor, there is a weak layer, or layers, in the coating system that may be the cause of major damage in the future. Over a large surface, the coating may appear very uniform and seem to adhere well, isn't flaking off or bubbling, but when damaged, it may show that the coating is only loosely attached to the surface underneath. A crosshatch test will reveal poor adhesion by peeling off entire squares of the grid, and sometimes even beyond. The very basic and very subjective test method involves the user cutting an X through the coating down to the substrate using a sharp utility knife. The blade of the knife is then used to determine how easily the coating lifts off the substrate at the intersection point of the cut. ASTM D6677 is the standard test method for evaluating adhesion by knife and contains a rating system table to evaluate the findings. No value is put on the adhesion strength of the coating. It is merely an observational rating/comparison to a predetermined set of parameters. This test relies on the interpretation of each tester, and it is therefore possible for the results to differ from user to user. A refinement of the knife method is the St. Andrews cross-cut test, so called as the cut angle simulates the white cross depicted on the Scottish national flag of St. Andrew. Using a sharp utility knife, the user cuts across through the coating, making sure that the angle between the cuts is 30 to 45 degrees, and each cut is approximately 40 millimeters, 1.57 inches, long. Special adhesive tape, ISO or ASTM, depending on the standard worked to, is applied with a firm force to the coating over the cross and pulled off at an angle specified in the standard to remove any loose coating. The scale shown is used to assess the adhesion. It should be noted that the latest version of ISO 2409 does not now specify a tape strength. Cross-hatch cutters. Further development of the cross-cut method is the cross-hatch method. Several cuts are made at 90 degrees to each other, creating a checkerboard lattice, and hence more intersections in the coating to assess. Whilst it could be argued that users could use a utility knife and a straight edge, it is not recommended, as achieving up to 11 or 22 parallel and equally spaced clean cuts is almost impossible, very time-consuming, and potentially dangerous. For this reason, cross-hatch cutters have been developed. Cross-hatch cutter is essentially multiple cutters aligned parallel and spaced 1, 1.5, 2, or 3 millimeters apart. When using a cutter, it is important that the user applies sufficient load to cut through the coating to the substrate, and that the load is evenly applied across the width of the blade. The cutter handle has a wheel at the opposite end to the cutter. When placed on the surface, the applied load is distributed evenly, both along and across the handle, ensuring consistency in the method. In all crosshatch cutter methods, the operator must ensure the cutter conforms to the test standard being applied. Standards specify the different tapes to be used. The relevant kits are identified as ISO or ASTM kits. The number of blades and the spacing are relative to the thickness of the coating being tested, whichever standard is being used. The crosshatch paint adhesion test kits have a wide selection of cross-cut blades to comply with the appropriate ASTM and ISO coating adhesion test methods. Blades made from hardened steel alloy for long life and are compliant with ASTM 3359 and ISO 2409. Normally, test kits come with all the accessories necessary to perform a crosshatch test. The crosshatch method. 1. 2 complete turns of adhesive tape are removed from the roll of tape, and a piece approximately 75 mm should be cut from the roll. The ASTM standard referenced the Permacell 99 tape as being suitable for the task. However, the Permacell 99 is no longer available. The ISO standard, ISO 2409, was changed to specify a similar tape to that used in the ASTM tests, the difference being that it was to be 50 mm wide and not 25 mm wide, as this tape was not commercially available. 25 mm wide tape was used, with a note added to that effect when reporting the results. ISO has addressed this issue by removing any tape specification from the standard. The standard now includes an appendix which states that the loose coating can be removed by brushing, adhesive tape, or blowing using compressed air or nitrogen. 2. The cut piece of tape should be placed over the lattice and smoothed down firmly using a fingernail or fingertip to ensure good adhesion between the tape and the coating. 3. The tape is then pulled off the coating. The type of tape and the angle at which the tape is removed are determined by the standard being used. The coating is then assessed by the user, and the degree of coating removal is determined by the inspector according to the standard used, ISO or ASTM, in accordance with the chart provided. The ISO 0 to 5 represents best to worst, whilst the ASTM 5B to 0B represents best to worst.